just have a couple more examples. So we have the Laplace transfer of cosine of pi t. And that's going to give me s over s squared plus pi squared. And sinh of 3t plus cosh of 5t. And that Laplace transform for the sinh of 3t, I get 3 over s squared minus that k term squared, so s squared minus 9. And then cosh of 5t will give me a 5 over s squared minus 25. Okay, so we can also use Laplace transforms on piecewise functions. But just like when we talked about improper integrals, there's the case that we have to break it up because at certain points we can't take the derivative, which means we can't integrate. So when we have that, we're going to have to break them up into the pieces so that our interval actually we can integrate over the whole interval. So just a refresher first of piecewise functions. So I have a function of 2 if it's negative 3 is less than or equal to x less than negative 1. It's x squared for negative 1 less than x less than or equal to 2. And it's 0 when x is greater than 2. So let's just sketch that out. So I just have a constant function of 2 from negative 3 to negative 1. So at negative 3, it's filled in, and then I go over to negative 1, and that one's also filled in. So here's my function. From negative 1 to 2, it's the function x squared. So at negative 1, I have an open circle, because negative 1 squared is 1, but that's not included. And at 2, I'm at 4. That is included. And then I'll just draw my parabola. And then from 2 on, the function is just equal to 0. So that's what the graph of that piecewise would be. So to take the Laplace transform on the integral like this, we just have to break it up. We can integrate on different pieces, but we can't do it overall because obviously this is not even continuous overall. So let's take the Laplace transform of this function f of t. F of t is 3, 0 less than or equal to t less than 2, and it's 0 when t is greater than or equal to 2. So obviously we have to break up our integral from at 2. So again, the Laplace transform is defined as e to the negative st f of t dt. So we're going to go 0 to 2, and from 0 to 2, it's 3 e to the negative st dt. And then from 2 to infinity, I get 0 times e to the negative st dt. Well, this is just 0. right? When I zero time anything, when I integrate it, it's still going to be 0. I'm sorry, when I integrate 0, I'm going to get a constant, and then when you subtract them, you're just going to end up with 0. So this term just goes to 0. So I don't have to worry about that. When I integrate this first piece, that 3 is just a constant I can pull out front. And integrating that, I get negative 3 over s e to the negative st from 0 to 2. So e to the negative 2s minus e to the 0. And then when you multiply that back through, e to the 0 is just 1. So I get negative 3 over s times e to the negative 2t plus 3 over s. And we can put those two, e to the negative 2s, I'm sorry. And we can put those two together. I'm running out of paper. I'm making mistakes. I apologize. So if I put those together, I would just get 3 minus 3 e to the negative 2s over s. Alright, so let's try another one. We want the Laplace of f of t when f of t at this time is defined as 0 for 0 is less than or equal to t less than 2, and it's t for t greater than or equal to 2. So our Laplace transform is going to be 0 to 2, 0 times e to the negative st dt plus 2 to infinity t e to the negative st dt. So this first part again is a 0, so I don't have to worry about that. This first term just goes to 0. And the second part, we just need to do an integration by parts form. So t1, 0, and then e to the negative st. When you integrate it, you get negative 1 over s e to the negative st, and then a positive 1 over s squared e to the negative st. So that integral, so that integral is negative t over s. When you multiply these, e to the negative st minus 1 over s squared e to the negative st from 2 to infinity. So I'm just rewriting it and bringing those negative exponents down to the bottom. And then I'm also going to just factor out this 1 over e to the st. And we're going from 2 to infinity. So when I plug in infinity, this term is just going to 0 because I end up getting 1 over e to infinity. So infinity would give me a 0. And when I plug in 2, I get 1 over e to the 2s. And then I'm multiplying that by negative 2 over s minus 1 over s squared. So multiply all those negatives through, everything becomes positive. So I end up with 2 over s e to the 2s plus 1 over s squared e to the 2s. And again, if I want to put them together, I just need to multiply this one by s over s. So I get 2s plus 1 over s squared e to the 2s.